For this question, it says, how long in years and months will it take for an investment to double at 4% compounded monthly? So I'm going to start with this part right here where it talks about compounded monthly, because this is an indication of what formula we need to use when we do this calculation. So because it says compounded monthly, I know I'm going to use the compound interest formula. A equals P times 1 plus R over N to the NT. P is our initial amount of money, or principal. R is our interest rate. T is time. N is the number of compoundings, or the number of times interest is added in 1 year. So because our question says compounded monthly, we are going to have 12 compoundings in a year every month, and N will equal 12. Okay, so reading the rest of this question, it says how long. How long is indicating that time is our unknown quantity that we're trying to figure out. We're going to use units of years and months in that answer. And we want our investment to double at 4%. That is our interest rate, R. And we will write that interest rate in decimal form, which is 0.04. So as I look at these numbers that are given, I'm going to go through my formula and notice that I was given the interest rate, I was given N, the number of compoundings, and T is my unknown quantity, so that's a question mark, and we're trying to solve for that, but it looks like I'm missing these variables as well, A and P. However, this information right here, which describes the investment doubling, it does not give us a value for A and P, but it does give us a relationship between those two. So the relationship is that A is equal to twice P, or double P. We are ending with twice what we started. And even though we don't know the values of A and P, because we know the relationship between the two, we're going to be able to solve this equation. So once again, I'll start with my formula. And I'm going to substitute everything I know into it. I'm going to substitute for A, that relationship of 2P. P stays P. R is 0.04. N is 12. N is 12. And T is my unknown. So let me simplify what's inside the parentheses there. I need to do 1 plus 0.04 divided by 12. And I might have to come back to this later because it is a repeating decimal. But for now, I will round it to 1.0033. If there's an issue later on with rounding, we may need to come back and add some more decimals to this spot here. And in the exponent, we have 12t. Now this is an exponential equation. Our goal is to solve for this value of t. And to solve this exponential equation, I first need to isolate the exponential. So our variable we're trying to solve for is t, and it's attached to this base of 1.0033. And I need that isolated on one side of the equation. To isolate it, I would divide both sides by p. That cancels out the p's on the left and on the right, leaving me with 2 equals 1.0033 to the 12t. And now I'm going to solve this exponential equation. The methods we typically solve with are to make the bases the same, which we can't do in this example. To convert to a logarithm, you could do that, or to take the log of both sides. My preferred way is to take the log of both sides. I'm going to do natural log on the left and natural log on the right. And then I'm going to use the power rule. And the power rule allows me to take that exponent and move it to the coefficient. I have natural log of 2 over 12t, natural log of 1.0033. And then I would divide both sides by everything except for t, so 12 natural log of 1.0033. We're doing the same thing on both sides. So that's going to cancel out the 12s, cancel out the natural logs, and I have t equals natural log of 2 over 12 natural log of 1.0033. We'll type this in our calculator to get the time. We'll type this in the calculator. I would put parentheses around your numerator and denominator, although in some cases it's not necessary. Like in this one, it's not necessary to put it around the numerator. But if you're not sure, it's better to put it in the denominator. I do need the parentheses to make sure I divide by the whole thing. That's 12 natural log of 1.0033, close parenthesis for the log, close parenthesis for the denominator. And we have 17 and a half years. Now, I remember in the directions, it's looking for years and months. So let's write down our value of t. T is 17.5 3258. And I think that'll be enough for now. So we did this problem in terms of years. So this 17.53258 represents years. And so if we take this part in front of the decimal, that's going to be the years. 17 years. And then we need to figure out the months. We're going to make the rest of this number, everything after the decimal place, represent the months. So this is years, this is months. But right now it's in years, so we need to convert it to months. So we're going to convert it to months since there's 12 months in a year. We're going to take that decimal value and multiply it by 12, and that's going to give us how many months. So let's do that in the calculator. So I'm going to subtract off the 17 that's in the front, and we're left with all the decimals, and we're going to convert this to months. So we're going to multiply by 12. That gives me 6.39, or just 6 months. We're rounding down to 6 months. So I'm going to zoom out so we can see the whole question for a second here. How long in years and months will it take for an investment to double at 4% compounded monthly? It will take 17 years, 6 months to double our investment at 4% compounded monthly. Thank you for checking out my videos. Have a great day.